this session. I hope everybody had a nice lunch, and hopefully this session will be interesting enough that your lunch doesn't slowly fade away into a little nap, but if so, well, at least you're comfortable. All right, so we're going to talk in this session about how we can kind of leverage AI to build APIs. If you think about AI, there's really no AI without APIs, right? You have models, and how you interact with models is via APIs, right? So if you think about, a typical AI-powered application, you have, something, and it calls a model via an API, whether that's through REST or WebSockets, SSC, gRPC, SCDIO, doesn't matter. It's some sort of API, right? And then depends on you which model you want to use, of course. So here's ChatGPT, for example. So I asked ChatGPT, what is Atlanta known for? And it answered with, some information. In this case, I guess, of course, Atlanta played a pivotal role in civil rights movements and everything, which is, a good answer, I guess. But if you inspect that call, you can see that it's really just a bunch of API calls, right? It returns the information depending on which application you're using, which tool you're using, and the inference model or the inference server of the model that you're calling, maybe the mechanics are going to be a little bit differently. But yeah, I mean, you really can't use AIs without APIs. So that's good to know. Specifically for OpenAI, you can see that they have an API spec for interacting with their models. And this is a specification that they have open sourced. We'll kind of leave in the middle the rest of OpenAI and why their company is called Open, but the API spec is open source, and you'll see that different providers of models also use this specific OpenAI API spec. There are other specifications for different inference servers as well, but this one seems to be kind of one of the more standard ones. So that's cool. They have nice documentation on how to interact with models. And if you're in the business of writing APIs, this should look pretty familiar, right? You can see on the left side, there's a curl call for chat completions with content type authentication JSON. Of course, it's very small. But you can see, this is fairly standard stuff. Now, can we use AI for API development? So kind of reversing the roles, right? We have AI that needs APIs to be able to work with AI, but what about using AI for API development? We can build APIs using AI, but how do we build APIs for AI, right? It's kind of a chicken and the egg question here because, yeah, of course, well, if you want to use APIs to use AI, and we use AI for APIs, well, where does it end? Of course, you can create an API without AI, so that's maybe the short answer. So when we are developing APIs, we usually do it in some sort of IDE or code editor or something, and leveraging AIs, done with code assistance. So we have a whole plethora of options out there. Maybe a question here, how many of you have used an AI code editor like Copilot or anything? So most of you, wow, that's really impressive. Yeah, so we have a lot of options out there. I'll use some of them to basically build our API, right? So this is how we see ourselves when we're using these code editors, right? These AI assistants. Wow, like it creates all this cool code and everything. But for a lot of those editors, for our bosses and our business owners, they kind of see it like this, right? It's like, wow, this is adding up quite a bit. If you're really starting to use it pervasively in your code, and that's a consideration to make, right? For businesses, where does the value start and end in terms of productivity? I think since most of you have used code editors, at least for me, my first interaction with it was like, wow, this is really cool. And then eventually it was kind of, like this trough of disillusionment, a little bit of, well, it created some cool stuff, but it needs a lot of massaging still. So in the end, did I really gain that much time? Yes and no, depending on what I'm building, right? So of course, choosing the right code assistant is going to depend on your use case. Some businesses require you to use specific tools. Some businesses say specifically don't use specific providers because of certain regulations or business decisions or whatever. So that makes it all a little bit more complicated as well. So I work at Red Hat. We like open source, and I was like, well, why not try some free open source software to do this? Because this is all costing a lot of money. It's all kind of semi-proprietary stuff. And I like open source stuff, and if I can use it for free, even better. And so that's kind of what we're going to see mostly in this talk is how can we actually build APIs using free open source software. So depending on your scenario, if it's for your personal projects or at your business, and you want to try out different models, you can actually do that, to some extent, running open source models. So the tools that I'm playing with here today are VS Code and IntelliJ for my code development, and then I'm using Continue and Klein to generate some code. So again, since most of you have already played around with code editors, you may be familiar with these tools, maybe not, and you'll most likely find that you've had maybe better success than I will have. And we'll see how that goes, because I will use these models also on my local machine. And so, why would I want to do that when there's these really performant models running out in the cloud? Well, of course, the first consideration is a lot of those models, or pretty much all of them, are paid, right? And of course, then you need to have a credit card, you need to pay for it in some way. If your organization pays for that, that's great. I wanted to run a model on my local machine, so I can just have everything running locally. That adds some convenience for me because I can just bring it with my laptop. It's easy to integrate. I can experiment with different models very easily. For the organization, this is potentially interesting as well because you can run your models in a kind of more secure place, right? Because if we're using models remotely while we're sending our code snippets or certain projects, pieces of our project over the line to potentially an organization that may be using that code to train their models, depends on your organization whether that's okay or not, right? In terms of cost control, I think it's pretty obvious. If you run a model, a free model on your local machine, of course, there's more cost control. And potentially there's, for some organizations, regulatory compliance. Now, the answer is not that simple of saying, yeah, we're going to just run models on our local machine. Why not? It's free. It's something that we can do. Of course, there are considerations such as the hardware on our local machine, because these models do use quite a bit of resources. And the quality of the models are going to be probably not as good because they're quantized, they're compressed, typically to run on your local machine, because we don't have a limited amount of GPUs on our local machine, if we even have them, right? So there's definitely some considerations to take. My thing was also really interesting because I was flying here, I was flying with KLM, and I get this message, trying to connect to the internet. I was like, oh, I have a 9-hour flight. I can get a lot of stuff done on the plane, and this happened, right? No in-flight Wi-Fi. But fortunately, because I was running a model on my local machine, I was able to actually get a lot of the stuff done that I wanted to get done. So, maybe an extra little bonus if you travel internationally, or you end up without internet for whatever reason. So when we talk about open source models, there's also kind of in the industry a little bit of let's say, flexibility about what constitutes an open source model, right? There's a lot of organizations that say, yeah, we have open source models, but what exactly does that mean? Open source to me means, it's code that we can access for free, we can contribute to, that anybody can modify, redistribute. Now, if you go to, let's say, to Hugging Face or something, you'll find that a lot of these models that are available are somewhat open source, but the rules of how you can use them are a little bit more restrictive than that, right? So a lot of them say you can't redistribute, you can't, you have to sign an agreement, you have to sign into, Hugging Face. So, Hugging Face is a place where you can find models that you can potentially download or run somewhere. So that's where you'll find a lot of the open source models. And then if I want to run a model on my local machine that exposes the APIs and that I can use for my projects, there's a couple projects out there. So the ones that I'm most familiar with are Ollama, Podman AI Lab, and Instruct Lab. They all have kind of their merits. Ollama is very easy to use. It's kind of the most popular tool, as far as I know, to run models on your local machine. Podman AI Lab has, a nice user interface, and it's using Podman Desktop. So if you're using containers, you just kind of add an extension to that, and then you can play around with it. And Instruct Lab is an interesting project, so it allows you to run models on your local machine, and potentially allows you to train these models on your local machine as well, if you have a lot of resources on your local machine. But you can also just use it to run models locally. So I'll use probably for the demos today, mostly Ollama, but I'll show you Podman AI Lab as well, because it's kind of interesting to kind of demonstrate the APIs that are being used as part of models. So I'm going to show you real quick how that works. So here is Podman Desktop, and so there's this extension here, AI Lab. And so this allows you to run models on your local machine. And you can see there's a catalog of models that are already loaded in there, and then you can import your own models. So you go to the Hugging Face website, for example, you find a model that you like, and then I believe it needs to be in this GGUF format. You download it, and then you can run it here. So I have a few of them already downloaded here. Let me just run one of them. I guess it doesn't necessarily matter which one. We'll try this one. And when you do that, the model inference server runs on your local machine. So right now, I'm actually running an AI model on my local machine. And you can see here, Access Swagger documentation. Oh, well, this is actually pretty interesting to see what is actually going on with this model. And so if you're familiar with AI models, you'll see that has endpoints, and this kind of depends on the capability of the model, whether it supports completions, embeddings, and then sometimes it supports tools and tokenizing and whatever more. So here we can actually see, what a model is exposing as capabilities, and then this is really the kind of the familiar playground that as API developers, we're very kind of familiar about, right? So here's an example of a prompt that we can send. In this case, what is the capital of France? But we can try out whatever we want. And then we can even try it out. So let's try it. What is the capital of Georgia? Let's see what comes out of it. So like execute this, running on my local machine. And of course, it takes a little bit longer, but not too bad, I guess, in this case. And then we'll see what the response is. So you can see here, just plain JSON. We get some information like the ID object and blah, blah, blah. And then at somewhere, we should see the response. Do you see it? I'm not seeing the response. It's got to be somewhere in there. Do you see it? Well, it's got to be somewhere in there. Anyway, I'm guessing it's Atlanta. What do you think? All right, so kind of just to show you, right, that this is what models do. They just expose APIs that we can work with. So then you have tools. So in a session this morning, we were talking about using LangChain for J with Quarkus. So basically what it does, it's a wrapper to interact with models using these kinds of APIs. All right, so we have different kinds of calls that we can make. I think I should have called the chat completions maybe. Let's try it out, try out, and then send it, execute, and then we'll see what the loading. If this time we're gonna get an actual response. And you can see running on your local machine, this is a fairly, has decent specs, this laptop. I had to bring my big old beefy laptop today. I also have like a smaller laptop that I travel with, but then things take a little bit longer. I think maybe it's not working so well right now. We'll try it again in a little bit. So you don't have to have dedicated GPUs for this one. So Podman AI Lab uses Llama CCP, which allows you to run models just on CPU. It also supports GPUs if you're running a Mac, which I'm not, which also kind of is maybe a detractor in this case. But yeah, so you'll see in the AI space that a lot of it, hardware focused for end users is like Mac seems to be the first class citizen, and then they'll look at the rest. There's a question? Yeah, so that's a good question. So what you're doing by just running a model on your local machine, you're not training it. So you're using a model that's pre-trained, and it's quantized, so basically compressed, but it has, kind of all that knowledge as part of your model, right? So think of it as kind of a big, kind of knowledgeable database. So we got a response, or not. What is this? Yeah. So it just took a really long time, and then the capital of, in this case, we asked France, and it did come up with a response. It just took a long time. But yeah, so yes, sorry, question? Yeah, so depending on the model, so I can show you here in Podman AI Lab in the catalog. So you can see that the typical quantized model will be around 5 gigs. But you have also smaller models, more specialized models. So you'll see that, for example, in Ollama. So here I can call Ollama and go a little bit bigger here, Ollama list. And you can see that I have some smaller models. So based on how much compression, quantization, you can see here this is a 3 billion model and it's 2 gigs. And then you have 20 billion model that's 11 gigs. So depending on how capable it is, the size is going to go up. The bigger the size, the slower it's going to respond too. So there's definitely a trade-off of like, which model do I want to use for the quality that it's going to return. So if you want to ask any model what the capital of France or of Georgia of the US is, probably you can use a very small model because that's pretty simple answer. But once you start using models for creating code on your local machine, you probably are going to need to play around with different models to see which one actually works the best. And also based on when it was trained, because of course, if we want to use some really recent projects, we also want to look at the dates of when it was actually trained, right, to see if that knowledge is embedded in the model. All right, so this is kind of a little bit of a sidetrack, of course, running models on our local machine and APIs, but it is kind of interesting, right? So we can use Podman AI Lab for playing around with models, and maybe just to kind of show you, you can actually create this playground if you really want to experiment with models. And the reason why I'm showing you this is that you can, kind of choose, I want to try to play around with this model or with this model. And then you can kind of start asking some questions and play around with, for example, temperature and tokens to see, where the balance is between creativity and, kind of deterministic well, it's never going to be deterministic, but more exact or more creative. So this is a nice way to kind of play around with the different options that you have when you interact with a model. All right, so oops, sorry, playing around with the slides here. So that's what you can do to kind of figure out what kind of model do you want to use, and then, like I said, Hugging Face is kind of like the GitHub for models, so that's where you'll find a lot of these models that you can run on your local machine. Question?
Do we need internet to run these models?
Do I need to?
Do we need to have internet to run these, or?
Do I need, sorry.
Do we need to have internet or Wi-Fi capability to run these?
Yeah.
Do you need internet?
No, you don't. So, yeah, sorry. So the example that I was showing with, when I was on the plane and I had no internet, so I was able to use my model just fine running locally. So you don't need internet to run these models. It's completely disconnected because it's running on your local machine. Yeah. So there's our good friends from IBM actually are working on this group of models they call the Granite models, which are, let's say, more open source than most. So they provide these models that you can potentially even contribute to. So there's a project called InstructLab that I showed earlier, which allows you to run things on your local machine, but it also allows you to create YAML files with knowledge and contribute to some of these models. So in terms of where the kind of balance is between open source and not, their models are actually not too terrible. So I'll try to use a few of those. And then another interesting group of models is, for example, the Llama models from Meta. So they work pretty well as well. Except there you do have to agree more with the license, and then they're not as open source. But so you can play around with the different models. All right, so now let's go to like the actual core of our talk here, which is how do we develop APIs, right? And if we think about the API development lifecycle, it goes a little bit like this, right? So you have, on the one hand, you have API consumers, you have API producers, and you need some sort of contract between those two to determine, like, hey, this is how we want to share our information. And so these API contracts are usually some way of maybe an open API YAML file that you can define. And the common strategy is that you first define the contracts and then you implement your APIs, right? So this is kind of where we should start when we develop an API. We should determine the contract and create the contract, and then based on that, develop our code. And then once we have that, we should probably make sure that our contract is valid. So there's tools out there to validate it. So there's, for example, Spectral, where you can lint through the OpenAPI spec and make sure that it's valid. So maybe we can try and start with a new project to create an API to get going. So the balance here is really with leveraging AI to create content, but then also making sure we verify what's being created and making sure that it's actually good and valid, right? So we need to use a little bit of our own experience, or a lot of our own experience, but also using tools to verify. So we can use other AI tools to verify that, but we can also use like more, let's say, deterministic tools like Spectral that are gonna say exactly, this is an error in your spec, so you need to fix that. So let's create a new project here. I'll try IntelliJ in this case, and we'll create a new project, new project, and we're just gonna do a blank project, so we'll call this Devnexus, and then create, and let's do a new window. Okay, so now if we want to get started, of course, we want to create an OpenAPI file, right? So depending on which tool you're using, you can even use an AI tool to create the files. In this case, I'm gonna use continue, which is a nice editor, but it doesn't create the files for me. Later on, I'll try to use Klein as well to create, scaffold some more of the code. So in this case, I'm just going to create a file. We'll call this openapi.yaml. And then we want to add some stuff to that. So I have this little cheat sheet in GitHub that my colleague actually created because this was originally his talk, and then he left the company. All right, so in this case, so I can prompt here, continue here, and so continue is a tool where you can select the model as many tools. And I already configured it, so I'll show you the configuration file here real quick. And so I have defined for the models to auto-detect provider OpenAI, but remember how I said OpenAI is not necessarily OpenAI as the company that provides ChatGPT and stuff like that. It's also that specification, right? So in this case, provider OpenAI with the API-based localhost 41139, which is what Podman AI Lab is exposing. So I could use models running on Podman AI Lab. And in here you can see that I'm also using auto-detect from Ollama. So any models that I'm running on Ollama. So Ollama basically is another way to run models on your local machine. And you can add models to it by basically Ollama, pull, or start, and then the name of a model, and then it'll start downloading them. So in this case, well, I already have this downloaded, but you can see if you're familiar with building and pulling and pushing containers, it's kind of the similar concept, right? So in this case, you can see I already pulled this, so it's able to tell me that, yeah, totally, I pulled it successfully. Yeah, because I already have it, of course. Otherwise, it would have taken a little bit of time because this one is 4.9 gigs. So now I have these different models already in Ollama, and because I'm using the auto-detect, if I can find my IDE here, as you could see, I could choose one of those models, right? So it says auto-detect all these different models, so let's try this one. And then let's ask it to create an OpenAI version 3 to create a pastry API. So you can see here, I'm just asking it to handle the create, read, update, and delete operations on an entity called pastry. And that's what you'll probably have already experienced when you're interacting with AI code editors. It really kind of depends on the prompting that you do, whether it's going to return something useful or not, right? So in this case, trying to be somewhat specific, saying that it should be version 3, and that it should create this pastry entity, include operations to retrieve all pastries. So let's try that. And in this case, it should, in a moment, return hopefully a spec that uses it. So continue wants to create a new file. This is actually new to me, so it is able to create files. Well, maybe, because kind of tried, and it looks like I got a null pointer exception. This is fascinating. So usually, if you interact with it, it just returns the text. So I'm going to see. I don't know if it's going to try to do something or not. If not, I'm going to disable tools because that's probably what it was. And try again. And this time, okay, here's. Yeah.
You don't need to use a locally running LLM.
Correct.
You could have asked, well, in your config, you could have pointed it to OpenAI.
Exactly, yeah. So you can, in your configuration, say, I want to use Claude Sonnet, or I want to use ChatGPT or whatever. And then it'll also call these remote models. So you don't have to use models on your local machine.
In which case, without having GPU and everything, it'll be much quicker.
Right. Yeah, I mean, the GPUs on your local machine won't matter then because the inference server is remote. So it depends on the GPUs of the server that you're calling. But if you, yeah, exactly. But if you're running on your local machine, of course, then
you probably came prepared to the possibility that you might not have internet here. Is that why you're running it locally?
Yeah, so that's definitely part of the reason. The other reason is that I just like to use open source models on my local machine. So I think then I'm not tied to.
As OpenAI, although it is from Facebook.
Which one?
Llama, which you are running locally.
Yeah. So I have.
Supports the OpenAI interface.
Yes,
Although it is
exactly.
completely different.
Yep. So it has its own API, and it also supports the OpenAI specification. Yeah. All right, so let's try that again because I was actually using the wrong window here. So I'm going to go to my YAML file here, hit enter, and here's my specification that it's creating, which it seems, this is always the cool part, right? It's like, oh, wow, this looks really cool. Looks rather complete, and then you can decide whether you want to use it or not. So I'm going to copy it into my file here, and then you can see here that it created an OpenAPI 3.0.0. I have a title, I have the version, I have a description, uses an example server, and then we can see get, post, put, delete, so that seems to be pretty complete, and then also a definition. So now,
it only had 200 response codes, not 503.
Correct, yeah. So that's something that we now need to kind of massage, right? So we want to interact with this file and make it perhaps a little bit better. So let's first kind of just try to lint it. So we need to create a file here from Spectral. So I'm going to create a new file, spectral.yaml, and then I'm just going to kind of cheat and use the extends that we already have here for OpenAPI. There we go. And now if I go to my terminal and I say spectral lint and then OpenAPI.yaml, let's see what it does. So now it's going to lint through my OpenAPI file, and I have some errors. I have some problems. I have 3 errors, which is actually not so bad. I think that's the best result I've seen so far. But there are errors, right? So what you could do is you can say, I'm just going to grab all these errors and then feed them back to the model and say, hey, fix that because you missed something. So there's a bunch of warnings and errors. So I'm just going to try to grab it and then give it back to the model. So this is always a little bit fascinating because sometimes this makes it worse and sometimes it makes it better. So let's see what happens. So what you can do with continue is you can just grab all the context here and then just enter an instruction, and then it's going to go inline and try to make some changes. So can you fix the errors? And then we'll paste the warnings and we'll see what happens. So we'll see now in a minute. So this is going through the file, and you can see, oh, it's actually including a developer Nexus team contact information, and then adding description, operation IDs, and whatever more. So it is trying to fix itself, right? Now, and this is where I like the fact that, for example, we're linting, so then we can actually figure out, is this a valid spec or not? Instead of trying to rely solely on models, we can use a little bit of determinism with the rest. So I think it's gone through the whole file. Yep. So I'm just going to accept it blindly. You should probably not do that. You should maybe review it yourself. But anyway, so let's lint it now and see if it got better. So let's see. Oh, look at that, 7 errors. So that's what I was saying. So you can iterate over this a couple times, and then what really helps is that if you give it 1 error at a time, and then it's usually a little bit better at fixing itself. So if we say like, hey, there's one specific error, and then we again grab the whole context and we do fix this error, and then it'll try to go through it and then fix that particular error. And sometimes it's still trying to make changes that it's not supposed to. This is where you have to kind of see which model works better than another model. So in this case, we can see that it's making some really big changes based on this one error that we gave it. So yeah, we'll see how it goes. But at the same time, you can try with a different model. So we could say like, oh, instead of Granite, maybe I'll use Llama and see if they have a better model for doing this, and then try again. And so it's a little bit of trial and error. So again, if you have the funds to use a remote model, most likely you'll see that the results will be slightly better, but of course then you're paying for it. So anyway, let's now assume that I have a valid OpenAPI specification. I'll go to my different project here and then grab the code real quick. So I'll go to actually, we'll go to the recent projects. And then I believe this one has a valid specification. Just to move things forward a little bit, let's find it here. And then copy and paste that. And then go back to the other window. There. Quick cheat. And then now, let's say that we iterated through this and we fixed our errors. So again, it kind of depends on your experience, right? I mean, if I had more time, I would go through the file and make sure that it's valid the way that I want it to. Now, Spectral is interesting because you can also define specific rules that you want to add to your validation. So in our case here, IntelliJ, yes, thank you. You don't want to overlay everything. You can see that if we add a specific rule to, for example, make sure that there's a contact information in your spec, you can add that to your Spectral linting YAML rule set. So we can try to use AI for that too. I don't know if you have that same problem, AI and API, like sometimes mess up sometimes I say AI instead of API and vice versa. Anyway, so let's go to the Spectral YAML and say, hey, add a new rule to this. So here we can say, create a Spectral linting YAML rule set that validates that the OpenAPI has the field contact with the email. And Hugo Guerrero will do Kevin Dubois instead, and then hit enter and see what comes out of this. Okay, so here we have it. So it's understanding that we're using Spectral, except it's using a kind of different format than what I was expecting, because this looks a little bit different. But you can see that it's trying to set these rules in a certain way. We can try it, and then we'll see what happens. I somewhat suspect that this is not correct, but we can try it anyway. All right, and then lint again, and I think it's going to error out. Yeah, invalid rule set provided, so it didn't actually give me the right rule set. So again, we can just kind of cheat and grab the rule set here, which says that it needs to be somebody from Red Hat that created these rules. So now if we validate again, we should see, okay, no validation with severity error found. So you can see that how we can validate the OpenAPI spec, right? Because it actually has my contact email. And then I also asked it to create the servers, localhost 8080, to make sure that I can test it on my local machine. All right, so now that we have this kind of API specification, we can start building our API itself, right? So a way that you can do this is you can say, create, I'm going to go ahead and go to my right project here. And then what I can say is, I'm going to do a little bit of deterministic stuff here, and then I'm going to add my API to it. So I'm going to create a new project. So you can do, for example, with Quarkus, which is a Java stack, Quarkus create app with extension REST, and extension open API, and then we can call this project my awesome project. And then this should create a new project on my local, in this local directory, invalid extensions. Let's remove that one, and then create my awesome project. And we'll see that it creates a new project here under Devnexus, my awesome project. There it is. And so what's interesting here is that it created a Java file, a greeting resource with path hello, and it returns this hello endpoint. Now, that's not what we wanted, of course. We wanted to use the spec that we created to create the correct endpoint. So what I can do is I can grab the specification, go to this file. So I want to call, I want to create a pastry resource. I'm able to do that pretty easily. In fact, I should refactor it from the file. Let's see, do that again. We'll do it here. Refactor, rename. I'm going to call this pastry resource Java. And then maybe the path can be /pastry. And now I want to add the right endpoints. So I'm going to chat with the thing here. I'm going to say edit, and then create the correct endpoints. Sorry, this is very small. I don't know why it's so small. Based on the following spec. And then paste the OpenAPI spec, which that's not what it is. I'll copy and paste it again. Copy, go to here. Okay. And then let's see what happens. So we'll hit enter, and then I'll try to make this a little bit bigger. So it should go through and start creating the endpoints for me. So this is where using AI is kind of handy, right? So it scaffolds a lot of the boring stuff for us. So in this case, we can see that it creates a post with create pastry. It doesn't implement the creation logic, that's fine. We have a get pastry by ID, we have update pastry, and we have delete pastry, which is exactly what we wanted based on the spec, right? So it's able to use the spec that we provided to it, and then it's able to create the right endpoints. So now, of course, our test, because we also have a test here, which is still based on the greeting endpoint. And we can also say here, let's do the same thing. Let's do edits, and then create tests based on the following API spec. And let's see what happens. So for running on my local machine, this is not terrible, right? So this may not be like super accurate as some of the tools that you've been using, but this is actually going a pretty far away. Now, what I like about this is that if we're using open source, we're also kind of encouraging all these providers out there that are making a lot of money that they should at least make their stuff open source, and that encourages competition and makes everything better, right? Because now we see that a lot of these companies are doing their solution and they're working in silos and kind of reinventing the wheel, each one of them. Whereas, you know, if there's open source, there's more collaboration, and I think that that'll improve, you know, the reliability of these tools and innovation a lot faster. So let's see what we created here. So a create test pastry and all that good stuff. Let's try that out. We'll go ahead and accept all. So we have a Quarkus test. It rewrote pastry resource test. So I should probably rename the file here too to pastry resource test. And then refactor, there we go. And then, yeah, let's use this JDK, that's fine. And then, yeah, we can try it all out. I'm suspecting this is going to fail pretty spectacularly, but why not, right? So we'll do Maven test and see. Oh, I'm not in the right directory. Hang on. CD, I forgot the name. My awesome project. And then Maven test should be pretty interesting. We need to download some dependencies, download the internet. So that's the part that we're not running disconnected, of course. We always need our dependencies. Let's give this a moment and see how many tests will fail. I'm guessing a lot of them. But in the meantime, we'll go back to the slides and then we'll revisit that. So this is an example of how you can interact with local models and the tool called Continue, which works reasonably well. But as you can see, even though there is a tool capability within Continue, it wasn't quite working for me, but maybe if I configure it more, it might also work. But you might have heard of agentic AI as kind of this next level of using AI, where your models are also able to interact with more capabilities outside of the model, right? So it's able to call external tools that have capabilities of, for example, built into these extensions. There are tools to access your file system, create files. They can access certain documents, or they can access browsers to find more information about specific projects that you're working on. So this is definitely something where the industry is going to in terms of IDEs and the editors that they're using too, right? So if you're using, for example, Cursor and you're using Claude Sonnet with it, you've probably already seen that it's able to create a lot more stuff than just a little bit of code. It's able to really scaffold an entire project interacting with different tools. So what's kind of interesting with APIs is that right now I showed you how to create like a fairly classic API, but like in the AI context, there's this kind of evolution that we see now with Model Context Protocol, where we can really use AI as an agent that is able to orchestrate and access different resources to augment its functionality, right? So the interesting part here, I think, for us as developers is that we can go beyond creating, let's say, plain REST resources for deterministic systems, but we can also create APIs that can be consumed by models. And that's kind of the idea behind this MCP, this Model Context Protocol. So it can actually, you can create tools that the model can use. And this is, in the end, is another type of API, right? So you can see here, for example, we have an MCP server that the model can use and consume to access certain resources in a database, or it can access a web API that in its turn can access a database or something else or some other resource, create emails or whatever it is. So this is another type of APIs and API development that I think we're really going to be developing even as Java developers. So here you can see Claude, which you can, for example, say, hey, I want to interact with my application, and I want to have it access its database to see the success rates of this particular API that I'm using. And it's actually able to process all that information, call a couple tools to access all the information, put it all together, so the agent that is running as part of that is able to orchestrate all these calls and then put it together, and then, in this case, provide some interesting information about, all the different heroes that we in our game are using. So you can see, oh, the hero that had the highest success rate was Black Panther, and then Iron Man. That's a little game that we have. And so basically, now we can use AI APIs for AI API development that can then be used for AI consumption, right? So this is kind of going into a really weird circle of, we can use AI APIs that then we can use to develop APIs that then are used to by the AIs to do something, right? So it becomes this really kind of Inception kind of story, right? It's that's the world we live in right now. So I just a quick example of a very simple MCP server.
Sorry.
Yeah.
I lost it. So you have a set of, in the first iteration, you have a set of APIs.
Yeah.
It's doing something proprietary, your specific thing. And then you have somehow, using the MCP protocol, including this in AIs in ours.
Yeah.
So the next iteration, when you ask AI, it's making use of the information coming through the AI, the APIs you created in the first place.
Yeah. Yeah, more or less, yeah. So these are, so in the first iteration I created REST APIs. In this case I'm creating a slightly different API because it's an MCP server, but it's basically the same as an API. So I'm going to show you here in the code, and hopefully it'll make a little bit more sense. So this is not the project that I was going to show. Let's see, let's find it here. All right, so here I have this, I created these code samples, and this is the client, here's the server. So this is an example of an API, of an MCP server. And you can see it does some things, right? So it has this tool that an API can call to return alerts for a weather service. And so we can describe it as, you know, 2-letter USA state code for the state, and then the description of my tool is get weather alerts for a US state. And then we have another tool, and these tools are basically APIs to consume by a model, right? And so we have a tool that gets weather alerts, and then we have another tool that gets the forecast for a specific location.
Where is the definition for, where is the import for the tool?
So the tools are part of, in this case, Quarkus. So we're using Quarkus in this particular scenario. So we're using Java, annotating as tool, and that exposes these tools as servers to be consumed by an AI model.
And behind the scenes, that will create endpoints which will adhere to this MCP.
Yeah, exactly, to this MCP protocol. So right now, we're using the SSE protocol. So basically, the model client ties into this SSE protocol to then connect with the tools that are running here, right? So we have two different things, and then on the other side we have a client. So this could, you know, be potentially a tool that you're using, could be Claude, or it could be, you know, in this case just another Java project that has that registers an AI service. So I'm using, in this case, we can see in our application resources which API I'm using. I guess in this case, I'm using OpenAI because I don't have anything specific specified, but I could also use a local model here that then would, if it supports tools, would call it to. But in this case, I'm using, I guess, ChatGPT. And then I provide this, I want to use this tool provider, which is the other project, to augment the knowledge of my model, because the models are trained a while ago. They have specific knowledge, but they have no idea about the weather today in Atlanta, for example, right? So, and that's what we can add by calling these external MCP servers to add specific knowledge to our API. So, yeah.
Does your LLM need to be running locally, as in you have the liberty to modify that LLM? You don't need that freedom? You be using like a ChatGPT?
Exactly, yeah. So in this case, I am using ChatGPT.
And they will call back
into
this in runtime?
Yeah, so my client is calling ChatGPT, but it adds the context of the MCP server, and it knows that when the response comes back, that it can call the MCP server for more knowledge, goes back to the model to then construct it as, you know, a nicely formed sentence of what the response should be.
So the MCP server is fairly heavy as well.
Actually, no. So my MCP server in this case is really, really thin, right? So I basically just have this one class where I register 2 tools, and in the business logic of these tools, I'm calling an external API in this case. So I'm actually calling from the tool to the weather service to get the information that I need. So this is very kind of a small piece of, relatively small piece of code that exposes a server running SSE that can be consumed. So let's try this out real quick. So if you were in our session this morning, you will already have seen this. But in this case, I start my MCP server that's going to serve this endpoint, right, with the different tools. And then on the other side, I'm going to run my MCP client that's then going to call the model and the MCP server, put those together to then provide me with the information that I want. So, and it's running a chatbot in this case.
Who's merging those two?
So that's the, yeah, so that's, so in the case with Quarkus and in LangChain4j, it's the libraries of LangChain4j that are orchestrating the calling of the model and then also integrating the tools. Yeah, so let's see if it works here. We got some handshake problem, but it seems like it's running. Let's try it out. So localhost 8081, and for some reason my UI is not starting. Let's see. Let's try it again. This is the other project. We can close that. And then let's see. I'm going to stop it real quick, start it again, and see if I can get my chatbot going. So the chatbot is running as part of this client, right? So we have an AI weather service, and then I have a chatbot here, a WebSocket from the backend side, which ties into the AI weather service here that I have registered that says you are a weather expert, get the most recent weather alerts. And then we'll get some information. So let's try it one more time. Localhost 8081. Yeah, for some reason it's not wanting to go to the main page, which is interesting. I don't know why it keeps redirecting. Well, anyway, so unfortunately I can't show this demo, but if you would, if it worked correctly, this morning magically it worked, but now it doesn't. I could interact with the chatbot and ask it, what's the current temperature in Atlanta? And it would, give me a nicely formed information of, the current temperature in Atlanta is, let's say, 65 degrees. And so the LLM would respond with the data that it got from the MCP server as well. So you can kind of marry the two functionalities together. All right, so let's wrap it up real quick. So hopefully this was interesting in terms of how you can kind of combine developing APIs with using a little bit of AI, running on your local machine. I didn't show Klein, which is another tool that you can use, which is also open source. You can use local models or you can use remote models. It's a little more capable of creating scaffolding projects. So if you're familiar with Cursor, it's kind of similar, but you can use it inside VS Code. But yeah, if you're already familiar with code editors, you may have some experience that also works. So I'm happy to hear some feedback of what works for you. But yeah, anyway, I hope this was interesting, and see you at the next session.